I'm going to describe a first application of a new instrument that we have put together at BYU, one that we've only been working on about a decade or so, but we are there and it works. And we're very excited about what's coming out of it, and that is a GC organic aerosol monitor for infill detection of fine particulate organic components. And you can read the folks that have been involved with the study. Let's see, which one do I want? That's the one I want. First of all, PM organic markers. These are just some examples. Levoglucosan, we heard about in the last talk, and we're going to hear about it in this talk, because it is a unique marker of combustion of cellulose, and so you can get it out of wood. Polycyclic aromatic hydrocarbons, there's a number of examples, tend to be emitted from vehicles. And cholesterol, interestingly enough, is emitted from charring of meats. And there are lots of markers, but those are just a few examples. And the instrument that we have put together is intended to measure those compounds in particulate matter on an hourly average basis. And I'm just going to run quickly through the instrument. It's really exciting. Paul Cropper has a poster. You can look at at noon that gives you details of it. But very briefly, we collect particles on a filter, thermally desorb them in an inert atmosphere, transfer them to a pre-column concentrator, which is really just a thermal cooling device, so that we concentrate them all into a single plug going into our GC. And you need to look at that in Paul's poster, because it's a beautiful piece of workmanship, and then transfer it into an ion trap mass spectrometer. The whole thing is about the size of a carry-on piece of luggage, maybe a little bit bigger than that. And so that's our instrument. And the study that I'm going to describe, which was our first application to source apportionment, was conducted in Utah Valley. That's south of here for anyone that's not from this area. And in Provo, we didn't look like this all the time, but when we've got a really good, strong inversion, we've got about a 500-foot inversion ceiling, so it's a great place to do studies. This is our study site was on BYU's campus. This is the view from the study site itself. That's the actual location of the study site. Now, it looks like it's surrounded by buildings, but actually, this is the hill going up to, this used to be the old, where I used to watch football games in the old stadium, so that we're up above the rest of these buildings out here. We've got a nice view over the valley. And of course, the wood smoke is not coming from the campus, which is roughly this area here, but from the community that surrounds it. So there's a look at the monitoring site itself. And the instrument that we have, we thermally desorb, and then we evolve for the gas chromatograph. And we're looking, for example, for levoglucosan. Levoglucosan has a peak with a mass charge ratio at 60. And a retention time that's there, is at about 1.6 or so. So we identify the compounds based on their mass spectrum and the retention time. We require both pieces of information to get positive identification of the compound. The data that we had available is detailed here. For those of you that have done a lot of sampling, these will all be familiar to you. Principal PM components, we measured mass ammonium sulfate, ammonium nitrate, organic material, black carbon and UV absorbing carbon, and fine particle scattering by the indicated techniques. I won't talk about the nephelometer results here, but I did when we were up at the visibility conference. We measured related gas phase species. The NOx, the NO2, the NOx and the CO, of course, are primary emissions. NO2 formation is dependent on the photochemistry that's taking place or other chemistry that's taking place. Likewise, ozone is a monitor of chemistry that's taking place. And you've already looked at these because you're looking faster than I'm talking. Are the organic compounds that we determined in this study. I'll emphasize in the very last study that we are not at all limited to just this list of compounds, but that's where we were at the starting point. Levoglucosan, we're going to focus on is from combustion of cellulose, dehydroabiatic acid from softwood combustion, stearic acid from mixed combustion sources, and pyrene and anthracene are 2 PAHs that we could determine in the data set. Now, there's a lot of data here. I want you to memorize every data point so you don't have any questions. There's PM 2.5. The important thing is that ammonium nitrate and ammonium sulfate, am I getting the right ones? I can just barely read it from over here, are the majority of the PM 2.5 nitrate and organic material, the majority of the PM 2.5. Black carbon and the UV carbon, they're down here, are highly correlated, and there's a morning peak. You can see it there, right there, there. However, it is reduced. That bar right there is the weekend. The morning peak isn't there. That's what you expect because the diesel traffic should be down. It's the major source, and so it's reduced. NOx and the CO are where are you over here? NOx and CO. There we go. NOx and CO, you can see, are very highly correlated. That's because they tend to be emitted together out of sources. The organic markers are in red, so you can pick those out easily. They're not particularly correlated, but they will be valuable pushers in connection with the source, with the PMF analysis. This is positive matrix factorization, the same analysis that was talked about in the previous slide. We first of all included all of the major gas and PM component data and only levoglucosan in an analysis, and then we did a second analysis including all 5 organic marker compounds. I'm going to go through the initial analysis quickly. This is a comparison of the experimentally measured PM 2.5 to the PM 2.5 described by the solution of the PMF analysis. The best solution contains 6 factors, and with an indicated chi-square and an error fit in the data, that's about what we think the uncertainty in the PM data is. Well, what did they look like? I'm not going to go through all the details, but I want to point out a few high things. The first 2 factors are associated with emissions from diesels and autos. This right here is the diesel factor. That's the UV and the black carbon, high as we would expect it to be. Here is our auto factor. It's high in CO and NOx, which you'd expect it to be. The third factor is dominated by ammonium nitrate. See, that's a big species there. It clearly is a secondary aerosol. While it has a little bit of other stuff in it, it's mostly ammonium nitrate. Factor 4 is dominated by organic material. It's got 4% black carbon and contains 62% of the levoglucosan. What would you call it? I'd call it wood smoke also. And there you can see is the contribution from wood smoke. Factor 5 is dominated by organic material, and in fact, it contains 35% of the levoglucosan, but very little of the black carbon. And I'm going to talk about why in the next slide. And this last factor is the material that is associated with ozone formation during the daytime, and of course, it follows, as expected, the pattern of ozone through the day. Well, 3 observations. The quantitative limit of levoglucosan is about 80 nanograms in this data. But we can see wood smoke in this analysis below that quantitation limit because the factor is not determined by levoglucosan alone, but by all the components in the levoglucosan. And so there's the predicted diurnal pattern for the wood smoke, and if you take a look at that, you'll see that very nicely. Wood smoke tends to peak during the nighttime, which is when it ought to. And this shows you the levoglucosan data that helped to drive that data right there. It turns out we had voids in the data during those 3 time periods. But the time pattern of the peaks in the organic material is very different from the time pattern in either the wood smoke or the levoglucosan factors. So why does it have a levoglucosan in it? I'm going to submit that it has levoglucosan in it because it is secondary organic material that is formed from wood smoke or gas phase organic emissions during the transport from wherever the wood smoke is burned to where we are. And so it has, and that's why the levoglucosan is associated with it, because it is associated with levoglucosan, or at least the spot where it was burned, but not only the PM, but also the gas phase species that are reacting. And you'll notice that that's also mainly a nighttime feature. Well, that's what the initial solution looked like. Wood smoke, as you can see, is, what is that, 20-something % of the total. Wood smoke is then a primary PM factor. The only other two primary factors are the diesel and the auto, and you can see that the wood smoke is much larger than either of those two. The remaining three are our secondary materials, and in fact the secondary material dominates the PM, 63%, but the levoglucosan is about, what is that, 20, you can read, you can holler that out for me because I can't read it from this angle. So our next analysis was to use all of the organic markers that we had measured. You can see the fit is pretty comparable, and in fact it is extremely comparable between the two analyses. And you'll see as we look at the data that in fact it didn't really change the results very much. The first 6 factors are really identical. I'll show you that on the next two. Factors 7 and 8, right there, we think introduce insights into the nature of the wood smoke, but probably don't represent a new source. And factor 9 is a factor that is associated with the anthracene. And there is a comparison of the two analyses for the wood smoke factor and the secondary organic material factor. You can see they're really unchanged by the two. There are the two factors that PMF pulls out that says are associated with stearic acid and dehydroabiatic acid and pyrene, but they only count for 3 to 8% of the concentration of the wood smoke. I submit that they are not really new factors per se, but they represent sources of the wood smoke and give us information related to how the wood smoke is burned. I think, did I skip over one? Yep, I did. So this is, so applying those assumptions that I just made, in fact, here's the comparison between the two analyses, really very comparable. But we do have a little better insight into the wood smoke itself. Our new factor right there is anthracene. You can see it really is a very small factor. We expect anthracene to be related to emissions from mobile sources, and in fact there's the anthracene solution, the auto emissions and the diesel emissions, and you'll see that they tend to follow one another, but the anthracene factor is not always present when the other factors are present. It is a subset of the mobile fleet, and we can't really identify exactly what that subset is from the limited data that we've got here. Well, so finally, here's what the wood smoke factor itself looks like. Of course, it's mostly organic material, small fraction of black carbon, small fraction of levoglucosan, a sliver of ammonium sulfate, and a sliver of ammonium nitrate, but those are not originally present in what comes up the stack. We have to remember that we're looking at wood smoke after it's been transported from where it's emitted to where we are, and during that transport process you get a little bit of ammonium nitrate that gets associated with it from the atmospheric chemistry that's going on. And so here's my summary. I got 52 seconds left. Huh? I better roll along. Well, I'll let you read it then. It just repeats a lot of what I've said, but I want to come down to the bottom one, because this is an important point. The PMF analysis was greatly aided by the use of hourly average data. The diurnal pattern drives the interpretation of the data, and we have been continuing on. We're currently looking at the West Valley Neil Armstrong Academy 216 winter data set. I'm in the middle of doing the PMF analysis on that. That data set is almost 3 times the size. We've got many more organic markers, and we are not at the limit yet. As we gain experience, we can pull literally dozens and dozens of organic markers out of the data that we get with the instrument. And thanks to those folks that gave us support. And I didn't mention it, but we studied where we were studying because of Argent Pope was conducting a health study there. And I think that's everything.